Welcome to Minute of Chem Every Day. This is 1.5, Electron Configuration. So electron configuration refers to how electrons order themselves around the nucleus and the notation how we describe them. Let's start with explaining core and valence electrons. Valence electrons are the electrons on the outermost level, or energy level, whereas core electrons are all the electrons in the lower levels, the ones closest to the nucleus. Now let's go over how things are ordered in the periodic table. So each row is a new energy level, or shell. And that means that if you're the fourth row from the top, then you'll have 4 energy levels, and that's how many rings are around the nucleus. From left to right is the number of columns, and that corresponds to how many valence electrons we have. So for example, oxygen is in the second energy level and has 6 valence electrons, because it's the second row in the 6th column. Now let's move on to the 2 configurations you will need to know. So electrons show up in the Lewis structure and in their levels electron configuration notation. So a basic Lewis structure looks like this: 4 orbitals which can fit 2 electrons each. And when we fill the orbitals, we fill them so that electrons are not close to each other because electrons repel. And this brings up a fundamental rule, Coulomb's law, which explains that opposites attract, so positive and negative will want to stay close to each other, and same sign charges will repel. So 2 electrons will repel each other because they're both negatively charged. And 2, the strength of magnetism relies on the charge and distance. So things closer to each other will pull each other closer. And when you have a 2 plus charge pulling in a 2 minus charge, then it will be stronger than a 1 plus charge and a 1 minus charge. Okay, now is the bulk of what every problem is based on, which is the notation. And how we write this is first the level, the energy level of our orbital, and then the type of orbital, either sp or d, and then how many electrons are in the orbital. And it looks something like this. So first you have your 1s2, which is your s orbital on the first level, and then you would go to 2s2, which is your s orbital on the second level, and so on. It keeps repeating until you run out of electrons. Okay, so you may be asking, what is sp and d orbitals? So first you would fill up the s orbital for each level. Those are the first 2 electrons in each level. The p orbital is 6 electrons in each level, and then there's d orbitals, which have 10 electrons in each level. Okay, for the first 2 levels, there's only s and p orbitals. Okay, so our d orbitals actually have a funky rule. We would actually fill our s orbitals of the level above before we fill the d orbitals, because we don't have enough positive charge in our nucleus to fit 18 electrons in one level. So we would fill that a level higher than the d orbitals. So for example, this is what it would look like. Okay, lastly, there's 2 types of notations you'll see. So we have the standard notation, which is the one I showed you, which is 1s2, 2s2, and so on. For example, this is magnesium. We also have noble gas notation, which means that we would put our gas, noble gas, which means the one on the far right, which is all the electrons in that level are filled. And then we would put the valence electrons only in this notation. For example, this is what a noble gas would look like. One more thing is ground level refers to only what's in the valence electron level, or the highest level. So it's like noble gas, except you don't need to include the noble gas part.